I will now write a truth table for two different Boolean expressions. The familiar P implies Q and another Boolean expression not P or Q. Why am I doing this? You will get to know in a minute's time. So let me look at the truth tables of these two expressions. So P and Q as and always. And then what is P implies Q? We know it is 1, 1, 0, 1. Okay, we have a not P or Q here. So I'll write down a not P for my reference. Not P would be 1, 1, 0, 0. So I should now write down not P or Q. 1 or 0 is 1. 1 or 1 is 1. 0 or 0 is 0. 0 or 1 is 1. Now pause and observe. Don't you think these two entries are precisely the same? Yes, they are. Okay. Whenever two columns are precisely the same, their corresponding Boolean expressions are equivalent. What do I mean by equivalent? Look, here is a Boolean expression. Let's say, Boolean expression B. Here is another Boolean expression, let's say B dash. And the entire column is the same, which means no matter what input you give for this Boolean circuit or Boolean expression, they agree always. When they agree always, we should say they both are exactly the same. They might appear different. So my P implies Q here and my not P or Q here are exactly the same, but they appear different. Such expressions are called equivalent Boolean expressions. Here is an interesting question. P implies and implied by Q, and look at this expression, P and Q or not P and not Q. Let us write the truth table of both of these expressions. P implies and implied by Q has the values 1, 0, 0, 1. And let's try writing the truth table of this, which involves writing the truth table of P and Q, which is this. And then the truth table of not P and not Q, which is this. And then OR of these two, which is this. What do you observe? I observe that these entries are same as the entries for P implies and implied by Q, which means these two expressions are equivalent.